Welcome to the Node Guardians YouTube channel, where we discuss all things blockchain, decentralized web, smart contract programming, and cryptography. I am Sam, and I am hosting this episode, as usual, with my friend Daniel Lumi, who is an independent researcher, consultant in all things ZK and beyond, decentralizing sequencers, provers, etc., etc. Speaking about sequencers, we have quite a specialist among us, another friend, someone I really respect in this space, Abdelhamid Bakhta, who is the exploration lead at Starkware, not to mix up with Starknet, which is the protocol. Abdel, I'm really happy to have you on the show. What's up? How have you been?
Very happy to be there. Thanks for the invite. Hey, Sam. Hey, Daniel. Very happy to be there. Yeah, it's always a pleasure to speak with you. Thank you.
I really look forward to diving into this episode and exploring the topics that we listed up for you. But before we do that, I would love to have a small introduction. I mean, I guess the audience would love to know a little bit more about you, how you got into that space, and what you exactly do at Starkware.
Okay, sure. So I come from an engineering background, specialized in computer science and electronic banking and system security. Then I was working on a fintech startup for 8 years, working on a cloud-based payment solution. So it was very interesting to learn about the financial system, the interaction between banks and card schemes like Visa, MasterCard, and whatnot. So I used to say that I was working with banks before fighting them. So then I discovered, Bitcoin. I played a bit in 2012, running some nodes and whatnot. But it was not enough to strike me hard to leave my job, etc. It was really when I discovered Ethereum in 2015. At this time, it was like a revelation to me. It was clear that I wanted to work on that space and fully dedicate my life to this technology. And more than the technology, the philosophical aspect of it, I see it as a real fight and a real opportunity to shape the world in a better way. So then I decided to move to this space. So I joined Consensus. I have been working as an Ethereum core developer for 4 years, working a lot on EIP 1559, which was a big change in Ethereum fee policy. So it was very interesting, not only on the tech level, but also the governance of a decentralized protocol, where you have some actors that have different interests, etc. Like, for example, miners were really opposed to this change in the protocol because it was reducing their revenue. So it was interesting to see how you can deal in action with on a decentralized protocol with a lot at stake. So it was very cool. Then after this period, I wanted to discover a bit more about Cosmos ecosystem. I was interested by the vision of multi-chain and interoperability. So I still believe the tech is very interesting, but I have some disillusion about some aspects of Cosmos ecosystem, like the reality, the different actors, and the fact that few projects contribute back to the stack, etc. And I'm also disappointed by delegated proof of stake at the protocol level and the fact that it ends up concentrating the voting power in few actors, especially because those actors know well each other among different chains. And I see it as a risk of concentrating too much the power. Anyway, just saying that at this time I missed Ethereum. I wanted to come back. Then I co-founded OnlyDust, which is something we can talk a bit more later because I still use the project I was building at this time, which is basically a contribution platform for open source projects. And my first task in this project was to choose layer 2 to build on. And I did an analysis of all layer 2 solutions and etc. My conclusion was that Starknet was the most promising. And a few months later, I met people from Starkware and so on. And then I joined Starkware. Yeah. And now I'm leading the exploration team at Starkware.
Well, welcome back to Ethereum, I guess. And you mentioned that exploration team. That's not very corporate. That's a bit vague, I guess. Could you tell us a little bit more about these explorations, the mission?
I imagine you guys with sticks and hats looking around.
This is not that far from the reality, actually. Yeah. I can tell you a bit more about the story behind the creation of this exploration team. So it started the end of last year, October, specifically during Starknet CC Lisbon, and you were the organizer of this event, which was an amazing event. So basically, there was Hacker House event with a building with many builders from Starknet community in this building, and I had a lot of interactions discussing with them. And at this point, I realized that at Starkware, we were too far from our own technology. I thought it would be cool to eat our own dog food and actually use and build with our tech to understand the pain of the builders and really have the feeling of their life with our technology and so on. I also realized that we have a lot of very young builders in Starknet ecosystem, which is amazing. I love that because they really think out of the box. But they can lack experience in running production grade software and so on. I had this idea of creating some high quality projects that can be showcase of best practices in the ecosystem, the best practices in terms of coding, security, testing, documentation, and whatnot. And last but not least, I wanted to really help to increase this mindset of collaboration in the ecosystem and this open source culture that we have on Starknet that is very dominant. And I really love the idea of having builders working together on some projects because then they learn best practices in those projects and they spread those practices in their own projects and etc. I really see a lot of synergies between projects because of that. Like, they build on the same exploration projects, they get to know each other, and then they realize that they have synergies between their projects and whatnot. So there was the goals of the exploration team. And the first concrete project was Kakarot, so this ZK EVM in Cairo, which was a perfect showcase of the power of Cairo. But I guess we can talk a bit more later about that because there are some actual synergies with Madara, the sequencer. So let's keep the topic for later, I guess. But yeah, this was the first exploration project, and then we started many more projects, and I'm really happy to see the community of those passionate builders that work together on those open source projects. And then they can even create businesses and companies on top of that. Like this is the example of Kakarot. So this is the story behind the exploration team and the goals.
So your most recent announcement was Madara, which is a shared sequencer network. And I thought it could be useful just for the audience to define, first of all, what a sequencer is like. Users can kind of think of sequencers as a normal blockchain node, like an Ethereum validator or Bitcoin validator. They have two functions in the blockchain. One is ordering the transactions and then executing it. A shared sequencer is essentially multiple kind of rollups using the same sequencer, right? Can you tell us a little bit more about Madara and what your sort of plans are with it? Is it part of the Starknet ecosystem? Is it official, canonical part of Starknet? Will it be the sequencer for L2? Will it be the official sequencer for all the L3s?
Okay, a lot of questions. Okay, very interesting questions. Okay, let me start by talking a bit more about the role of a sequencer. Okay, so basically this is the architecture of Starknet. So as you said, basically the role of the sequencer is mainly to take transactions from users, order them, and then execute them and produce blocks, because ultimately layer 2 is a blockchain with some blocks, and in those blocks there are some transactions, etc. But yeah, really the main goal is to pick transactions from users and to order them and to execute them. So this is really the execution engine of the validity rollup. And as you said, you can see it as a normal node. So you have also the mempool of transactions. Then you also have a state, which is the representation of the state of your blockchain, in this case, the state of Starknet, for example. And then when you create blocks, those blocks need to be proven. And this is another entity that takes this responsibility. So the prover, and the prover is capable of proving blocks and transactions. And how we do that, because basically the sequencer, as its core level, runs the Cairo virtual machine. And Cairo is basically a language that enables you to write provable programs. Like that means that when you write a program in Cairo, you will be able to prove it using zero-knowledge proof technology, but you don't have to bother with math and all the stuff that happens under the hood. Ultimately, you just write your program in a high-level language that is Cairo, and the Cairo virtual machine is capable of running Cairo programs and generate execution traces that are needed for the prover to be able to generate Stark proofs. And then those proofs are submitted to the layer 1, in this case, Ethereum. So on Ethereum, there is a smart contract which is capable of verifying those Stark proofs. And then if the star proofs are valid, the state root of Starknet is updated on the layer 1. And the state root is basically a representation of the whole state of Starknet using Merkle trees, exactly like on Ethereum. But yeah, this is really the architecture of the validity rollup. And this is concretely the role of the sequencer, basically. And yeah, then you asked me some questions about the role of Madara specifically. So basically Madara there are two main tracks. The first one is it's a candidate to be an implementation of the sequencer for the public Starknet, the Starknet itself, the layer 2. It can be, obviously, at some point, we might want to have some client diversity, like on Ethereum, with multiple implementation. So Madara could be one of those possible implementation of the sequencers. So client diversity is very important. It's important for bugs. Like, for example, if you have multiple implementation and you have a bug in one implementation, the network can continue to operate seamlessly because of the client diversity. And we saw that in action on the Bico chain recently. So client diversity is very important. Also, when you have multiple entities working on different implementations, you have less risk of an actor injecting a malicious backdoor in the code and etc. So Madara could be one implementation of the public Starknet sequencer. So this is the first part. And then it's also a very good sequencer for Starknet appchains. So I can maybe talk about what is a Starknet appchain and why Madara is very well suited for those appchains. So a Starknet appchain, basically, there was this article on the Medium of Starkware about fractal scaling. So the idea is that you have the L1, then you have the layer 2, and then you can have some application-specific chains on the layer 3. An application-specific chain is basically a chain that is sovereign. It can run its own set of sequencers. It can be also a centralized sequencer. But really, you have this idea of having a chain that is focused on one use case, for example. So it gives a lot of benefits, but we can talk about that probably later. But yes, this is the idea of an app chain. So you have your chain that is focused on one application-specific use case. And Madara is a very good candidate for that because it's a very modular sequencer and flexible. And you need that for app chains because app chains have different needs, different requirements, different constraints. So the more flexible and modular you are, the more you can fit different needs for different app chains.
From your answer, my guess would be that this is not going to be the canonical sequencer for Starknet the L2, but it might be an extremely interesting solution to quickly bootstrap an app chain, Starknet L3, on top of the L2, and basically build any kind of business logic on top of it. It could be suitable for games, but also, I don't know, maybe some kind of trading protocol, God knows what. And what is interesting also is that all this Madara-powered Starknet that we could launch, they can just use the shared prover on top of Starknet the L2, if I'm not mistaken, and benefit from scale, cost reduction, let's put it this way. That's very interesting, and it seems to align a lot with what we see lately in the space. We have a lot of bootstrap to roll up in 2 clicks with Conduit or Outlayer or Sovereign Labs, maybe create your roll up with your custom VM, etc. in the blink of an eye. And I think that this is definitely an interesting need that's growing in the space. People are looking to have their own, let's say, block space, their own environment, while inheriting from decent security guarantees. And I guess that's the reality you guys are trying to go towards, right?
Exactly. So yeah, I can say a few words about the benefits of an app chain and why this is important. So as you said, when you have your own app chain, first of all, you can iterate quickly on the protocol. You can do some changes because you are not dependent of the roadmap of the public layer 2. So that means you can do a lot of innovation because you don't have the constraints of having a decentralized governance protocol. Let's say you own your own layer 3 for a DeFi project. You decide the features you want to implement in your protocol, and you don't depend on the roadmap of the public Starknet. For example, on the public Starknet, if there are some missing features on the protocol, what you can do, you can obviously try to make that happen and create a SNP, a Starknet improvement proposal, but then you will have to convince people that it makes sense, eventually do an implementation. So this is very long road to have a change included in the protocol, and you have no guarantee that you will end up being able to push this change in the protocol, where on your app chain, you have full flexibility, and you can implement new features on your sequencer without asking anyone or without requiring to update the protocol of the layer 2. So this is amazing in terms of innovation. So another important aspect is the cost reduction, because the same way the layer 2 gives cost reduction compared to the layer 1, because you use validity proofs and verifying the proof is exponentially cheaper than recomputing the computation itself. And you can apply the same thing on the layer 3. And then, for example, let's say if layer 2 provides you 1000x cost reduction, if you use the same mechanism, you can also have the same 1000x between the layer 2 and the layer 3. That means ultimately you have a 1 million x cost reduction between the layer 1 and the layer 3. So this is very interesting, and that without losing the security guarantees that you have. There are some caveats around censorship resistance and so on, but essentially you don't lose the security guarantees. So cost reduction is very important. Flexibility. So you can imagine a lot of use cases that are not possible to do currently on the layer 2. For example, privacy-enabled application on the layer 3. So this is this is very important. I really want to see privacy-enabled applications on Starknet ecosystem, and this can be done on appchains before it will happen on the layer 2. So at some point there will likely be some privacy on Starknet, but it will be easier to do that on appchains because, as I said, there are no constraints and people can innovate. So it can be seen also as a canary network for the public Starknet, where you can see a lot of innovation in different chains, and then we can say, okay, this makes sense, and maybe we want to implement that on the layer 2. Another example is about very low-level stuff, like, for example, on Starknet, we use 252 bits prime field. This could be improved, and in the future, we would like to change to use Goldilocks, 64 bits prime field elements, but it will be a lot of engineering work, etc. So maybe we can try to do this work on the layer 3, implement everything, and then have a very good view on how to do that on the public Starknet. So it can be seen as a canary network for the public Starknet as well. You don't have congestion issues on your app chain because you control kind of the traffic, and all the transactions will be the transaction of your application chain, where on the public Starknet or any public blockchain, you have this congestion effect where if there is a sudden spike in usage of the chain, everyone is impacted kind of. So you don't have that on your app chain. Yeah.
So you mentioned, and Sam also mentioned, the ease of deploying an L3 or an app chain and being able to swap out the parts, maybe the virtual machine, maybe the fee token. And I'm curious, I know you guys are built on an implementation of Substrate, which is, for the listeners, a framework for building blockchains. I'm curious, how can you swap out languages? Can you swap out the virtual machine? Could we make Solana L3 to make it a little bit less trustless?
Yeah, very good question. So yeah, we use Substrate to build Madara. As you said, Substrate is the framework to develop your own blockchain. The idea is that you have some components that you can pick and you can swap them, customize them if you want. But the idea is really to use battle-tested primitives that already exist instead of reinventing the wheel, kind of. For example, you already have a networking, peer-to-peer, storage, everything implemented using Substrate, and then you can focus on your blockchain runtime. And the runtime is basically essentially as a state transition function of your blockchain. This is really how you go from a state to another. So essentially, this is where you have your execution engine and all the rules of your blockchain. So what we did is basically we took Substrate. So this is the architecture of Substrate. So basically a Substrate node is everything. So this is the yellow box. And then you have two main parts in the Substrate architecture. You have the client side and the runtime. So the client side is everything that is connected to the outside world that is not on-chain per se, like the networking stack, peer-to-peer mechanism, transaction pool, RPC layer, monitoring function, etc. And the runtime is really the state transition function. So this is where you will put actually your execution engine. And in this case, we use the blockifier. And the blockifier is a component developed by Starkware that basically encapsulates the Cairo virtual machine and adds Starknet custom logic, like, for example, the syscalls, etc. I don't want to jump into too much details, but the blockifier is basically the execution engine at the core level. So this will be more or less the equivalent of the EVM. Okay. Then you have the blockifier, and you integrate it in your runtime, and then you have your whole blockchain. And the good thing with Substrate is that we can focus only on this part and directly use some components that already exist. And then when we want to change some components, because, for example, we want to implement a custom consensus, we can decide to not use existing components and implement our own components, etc. But I guess we can talk more about that later when we talk about decentralized sequencers, etc. But this is the core idea of Substrate. And this is the idea of using Substrate for leveraging battle-tested primitives and focus on the runtime. And there are some cool features when you use Substrate. For example, the fact that the runtime compiles to WebAssembly. That means that you can do forkless upgrades. Basically, in a network like Ethereum, when you want to change the rules of the protocol, it is done through a hard fork. So you need some kind of synchronization, nodes need to be updated, etc. With forkless upgrades, the idea is that you can gossip the code of your runtime itself through the network and upgrade without having this coordination effort. So obviously you need to couple that with a governance mechanism, because you don't want anyone to be able to update the core logic of the protocol, but you can couple that with, token voting based system or whatever mechanism you want. And it will be enforced in the code. Like, for example, we saw some kind of drama with Arbitrum not following the result of a vote, etc. So with that, it cannot happen. You couple that with the voting system, and it will be enforced by the code, and the blockchain will be upgraded automatically after the result of the vote, for example. Or you can decide to do it in a centralized manner and have a single entity that is allowed to upgrade the protocol of the blockchain. But this is really up to you. You can develop whatever mechanism you want. So this is a powerful feature, the ability to be able to seamlessly upgrade your blockchain without upgrading softwares and coordinating nodes and etc.
And because Substrate compiles down to WASM, there's other languages that we can compile down to WASM, like Move or C or Python. So the question is, like, how easy would it be to make a SDK for those languages as well, and then use different languages, or maybe a different virtual machine like Arbitrum compiles down to WASM as well?
That's an excellent question. So basically, yes, we could integrate another virtual machine, another execution engine, anything that could compile to WASM. We could integrate it into Madara. The problem is that if we integrate a non-Cairo based virtual machine, it won't be probable. So not probable. We can do that. We can integrate another virtual machine, and we would have a layer 3. But what would it mean in this context if we cannot submit proofs to the layer 2? We would not have the guarantees of a validity rollup in this case. So what we could do instead, and this is some kind of inception, is implement the virtual machine in Cairo so that it becomes provable, and then integrate it in Madara. And there is one concrete example of that, which is Kakarot. Exactly. Kakarot does that with the EVM. Because Kakarot is the implementation of the EVM in Cairo, that means that a program running on Kakarot is provable. So if you couple Madara plus Kakarot, that means you have a sequencer that is capable of running the EVM through Kakarot. And then you have a ZK EVM-based layer 3 on top of Starknet, which is very powerful. So the answer to your question is that in theory, this is possible. We can integrate whatever virtual machine you want, but the difficulty will be to implement those virtual machine in Cairo, which is non-trivial thing. But yes, in theory, we could. If someone implements a Cairo-based virtual machine, Solana-based machine, or Move or whatever in Cairo, then yes, we can integrate it and make it provable. But otherwise, if we don't care about the validity proofs, yes, we can integrate today other virtual machine. We could imagine, but no, seriously, I mean, there could be some potential use cases where you want to have an hybrid chain that is capable of both running provable computation and for some other part, non-provable computation. So with Substrate, we can do that. We have the flexibility to do that. Those, like, for example, you can enable some different types of transactions. Some will use non-provable VM, and others will use the provable VM. And depending on the guarantees you want for your application, you might want to choose one or the other. But essentially, if we want to have a validity rollup based mechanism, we need to have the virtual machine be able to run Cairo programs at the core. Yeah.
In regards to interoperability between L3s, I believe that the substrate stack has its own component when it comes to this, some kind of light client bridging mechanism called XCMP. We have the same for Cosmos SDK-based chain, IBC, and we see a Cambrian explosion of inter-L3 or inter-blockchain communication frameworks with state proofs, Lagrange labs, Herodotus, storage proofs, you name it. In regards to interoperability, what do we have on top of Madara? Are there any components that benefit from the fact that it's built with Substrate? Can we leverage existing frameworks that Substrate is known for? Or it will depend on the consensus we implement on top of it? Should we decide to decentralize the network of Madara nodes? Could you tell us a little bit more about that? Because I think that interoperability is quite a big thing in this nebular network of L3, L4, L7, etc.
Really prevent like user experience fragmentation or just liquidity fragmentation.
Yes, it's very good question. So yes, we could try to leverage some substrate-based mechanism like XCM, like you said, this messaging framework that would enable us to communicate between Madara appchains. It could work. The problem is that, again, if we don't care about client diversity for appchain, then it works because all of them would use the same framework. But if we still want to have this possibility of having different kind of implementations, maybe it will be better not to rely heavily on a substrate-related messaging framework. I don't know. It's an open question. Maybe it's totally fine to not have the client diversity on app chains because those are not the same trade-offs. You don't have the same requirements for an app chain layer 3 than you have with the layer 2. So does it make sense to have client diversity on your app chain? Probably not, because it's very likely that there will be one entity that will decide all upgrades and etc. So it will be more overhead to maintain multiple implementations than benefits. So maybe it's fine. As you said, one interesting thing is that because all of those app chains would use validity proofs, then we can leverage this and do exactly what, like you said, with Herodotus and using storage proofs plus validity proofs. And then you are able of seeing what happens on other chains because you are able to verify the validity proofs. So basically, if you implement the consensus rules of a different chain and you implement all the logic in Cairo to verify the rules, then you are able also to verify them and you are able to trustlessly prove what happens on a different chain. This is also the concept of ZeroSync that does that with Bitcoin. They have implemented all the Bitcoin consensus rules in Cairo. Then you are able to prove the Bitcoin chain. So yes, I think this is very interesting design space. The fact that all those app chains use validity proofs, it will enable very interesting interoperability design. So we are working in collaboration with Herodotus. I don't want to spoil, but Marcelo came up with a very interesting design that could be implemented on Madara. We will explore more that in the coming months on Madara. This will be very important. But first, I want to make sure that we are able to run seamlessly Starknet appchain layer 3. And then once we have adoption, we can start to think about how to connect them together. But yes, this will be a very interesting design space for sure.
Okay.
Yeah.
The first thing I'm doing after this is contacting Marcelo for details. I'm curious, like one of the cool things that could be possible through shared sequencers, and just to expand on the interoperability a little bit, is not just bootstrapping a network, but being able to have, again, a sort of pseudo-atomic composability between different blockchains, because every one of the app chains would use the same set of sequencers, so they could essentially agree on when a transaction's included and then execute it on the other chain without having to sort of have extra trust assumptions. How much have you guys sort of looked towards that path, done research towards that path, or is that something that's like in the future?
Yeah, more in the future, to be honest. I think I'm yet to be convinced by the shared sequencer design space. I think this is promising, but I still have some concerns about how it can work in practice and whatnot. But yeah, this can be an interesting direction in the future. And for sure, it will bring some very interesting composability, but I'm not yet convinced about how it can work in action especially with small chains, I would say, that are not secured by a lot of economic security, etc. So I'm not saying that we don't want to explore this direction. I think we will, but I want to see other players in the space and what they will do and what challenges they will face and whatnot. So I would not say this is our priority for the moment.
There's no exploration here.
Yeah. But yes, this will be an interesting design space for sure, and I will follow actively those projects that are working on that, and definitely willing to support any initiative if someone wants to explore that direction on Madara. Again, this is an open source project, and we strongly encourage people to come and hack, implement whatever they want. For example, in a few weeks, early June, there will be a hackathon, and there will be a Madara track, and we encourage people to implement many things like, for example, Celestia as data availability layer or EigenDA. Really, we want to be as modular as possible with Madara, and really want people to hack and implement crazy features on top of Madara. So as I said, Marcelo is a good example. If you want a keyword to ask him for alpha, the keyword is turbo. Ask him about turbo transactions, and he might give you some interesting alpha. So yeah, we really want to encourage this open source contribution on Madara, and there are no limits. I mean, we want to be very modular, use different kind of data availability layer, etc. I want to talk a bit about the importance of decentralization of the sequencers, because I think there are a lot of confusion on this front and why it's important, why it is not the same question as decentralizing a layer one. So if you guys want to talk about that, I think it can be interesting.
That was going to be my next set of questions, actually.
Okay, nice. Very cool. So yeah, please feel free to ask me what you are, or we can jump directly if you.
Yeah, well, I'm just kind of curious of what your plans for decentralization.
Okay.
What will the fee token be within the sequencer network? Because the app chains can have different free tokens, but to inherit that same level of economic trust, you probably need to use one token in the sequencer network, or at least do like swapping. And I'm just kind of curious from both an economic security point of view, as well as then like how do you implement a random leader election, and just any details you can sort of dive into on how you're planning on doing that.
Okay, so first of all, I will say a bit about why it is important and why it's not. So basically, currently, all layer 2s are centralized, including Starknet. So there is concretely one entity that is Starkware that runs the sequencer and the prover. And it's fine for security reasons. I mean, Starkware cannot operate maliciously because it cannot generate valid proofs. So everything that goes to the layer 1 is valid. You have this guarantee. Even if in a centralized context, you cannot mess up with the integrity of the chain because the state root is on the layer 1, and you can only change the state root with a valid transition that is proven mathematically. So it's math security. It's not economic incentives and whatever. It's very important to say this because this is not the same problem as we have on the layer 1, for example. So, but the problem is that there are two main issues. The first one is censorship resistance, and the second one is liveness. Okay, liveness is simple. If you have one entity, obviously you have more chances of the network to go down and to have some issues, etc. So for liveness reasons, the network provides more resilience, etc. So it's pretty easy to get that. This is why it's important to decentralize the sequencer. And on the censorship resistance front, okay, when you have a centralized sequencer, obviously, to submit transaction, you need to submit them to the sequencer, and the sequencer has the power to include them or not include them. But you can say that this is the same also on Ethereum, for example. A validator is not forced to take your transaction, but because of the decentralized nature of the network, if someone censors you, you can still be included in another block. And even if 90% of the network censor you, you will still be able to submit transaction. So it's a good way to mitigate censorship. Another one is forced L1 transaction, giving the ability to users to submit transaction directly to the layer 1. This is also called the escape hatch. We have that, for example, on StarkX, which is a Validium solution that uses validity proofs, but the data off-chain. So this is a Validium. This is the main difference between StarkX and Starknet. StarkX uses off-chain data, and also it's not permissionless. It operates as a Validium, but surprisingly, it has very good security guarantees because user can submit transactions through the layer 1. So the operator, even if centralized, cannot censor transactions of user. So this is very powerful. At some point, we will implement that on Starknet, but it's harder to have a generic escape hatch that works for any kind of applications. So it's easier to design an escape hatch for a specific use case. So that's why one of the main mitigation of censorship will be the decentralization of sequencers. Then how to decentralize the sequencers? So Ilya from Starknet started to draft some proposals for decentralization of sequencers. So basically, you can see there are 4 main functions in this topic. So the first one is the leader election. Then you have the consensus mechanism itself. Then you have the production of proofs, and then you have the state update. Okay, so for the leader election mechanism, the idea is to leverage the layer 1. And basically, the idea will be to have the staking happening on the layer 1 itself. So the sequencers of Starknet layer 2 will stake on the layer 1 in a smart contract on the layer 1. And this smart contract will be used for the leader election mechanism on the layer 2. That means that the layer 2 network will interact with the contract, and the randomness and the leader election will be determined by what happens on the layer 1. So we really want to leverage the maximum the layer 1 to limit the trust assumptions, etc. So the first part is the leader election. So we need to interact with the smart contract that will handle the staking directly on the smart contract on Ethereum. Then for the consensus, there are many possibilities. So it seems that we will go first with a BFT model. So basically, there are 2 main possibilities. Either BFT is your longest chain or a mix of both, like gas pair, for example. So we will go probably with BFT first, mainly because it's simple and we don't have also the same requirements for the layer 2. I mean, one important factor is that we don't aim for millions of sequencers. This is not like Ethereum where you target a very huge number of validators, etc. So we don't aim for that because, again, as I said, we don't decentralize for the same reasons. So, for example, it's very likely that even 100 sequencers will be probably more than sufficient for layer 2. So that means that BFT could be the best possible solution because they are efficient, simple, and performant for a pretty reasonable set of sequencers. So we'll probably explore BFT and more specifically probably Tendermint. We will probably explore that direction, and maybe we'll try to do that in Madara because, again, it's still possible that Madara can be used for the public Starknet sequencer, and it's a good way to iterate and implement some research-related stuff on Madara because we have a kind of flexible framework. So maybe we can try to implement the decentralization proposals in Madara. Okay, so leader election.
That's mainly for simplicity, right? Instead of using something like hot stuff, Tendermint, you can just kind of deploy it. Okay.
Exactly. Mainly for simplicity. Yeah. Simplicity and efficiency. Simplicity is very important criteria there. Yeah, definitely. And I mean, simplicity is always good for security. I dream of a world where Ethereum will be less complex, actually. So we all want simplicity. And actually, reducing complexity is good also for security, for many, many reasons. So simplicity is very good. So, okay, leader election based on layer 1 contracts, consensus that will likely be BFT style. And then we have the proof production and the state update. You can read the proposal from Ilya on the community forum of Starknet. They are more complex, so I won't jump into details there. But yeah, there are very interesting proposals, decentralize the production of proofs, etc. So something that is quite complex in this model is that because we have 2 kind of entities in the network, like there are sequencers and provers, they have different requirements, different constraints, they do different stuff, but they all need to be incentivized, of course. So the fee market will be very complex because it's a multidimensional problem with different kind of actors, different kind of resources, computation resources, storage, etc. So this is not an easy question. This is why it takes time to actually decentralize the sequencers. But I think Starknet, we are very well positioned to do it in the right way and in a pretty good timeline, hopefully. And Madara is a good opportunity to iterate quickly and try to implement and play with different kind of flavors for decentralization.
And I just want to stress quickly the same thing that you said, that in L2s, sequencers are not for security. It's for liveness and censorship resistance. There's a lot of misunderstanding, especially people from other ecosystems that don't understand that the consensus mechanism on top of like a decentralized sequencer network does not affect the security. It just affects a very short finality.
Yes, exactly.
You have the design, whether it is an optimistic one or a validity proof based one that is here to actually, let's put it this way, enforce security for the rollup. And speaking of the provers and potential proof markets, I think Neil Foundation is trying to tackle that problem. Snarket bases and all the different approaches to price resources and make decentralized networks sustainable on that aspect. It would be nice to quickly cover the subject of the relationship between sequencing and proving. I think there's a misconception which suggests that the main bottleneck would be the prover and not the sequencer, and vice versa. I've seen you Twitter fighting lately with some folks over at Solana Labs over this matter. Yeah. It would be interesting to have your take regarding optimizing sequencing and what to catch up on when it comes to proving. Is it really that parallelizable?
Yes, there is a clear asymmetry between the sequencing and the proving. They are very different because the sequencing is sequential. So for the moment on Starknet, with Cairo, we can run only sequential transactions. So we have plans in the future to be able to run transactions in parallel. But for the moment, this is sequential. And the proving is not sequential. It is done asynchronously and in a parallel manner, especially because we use proof recursion. That means that you are able to split a big proving task in multiple tasks and then use a recursion mechanism to be able to catch up, because you can distribute the proof generation in a very large number of machines. So you can scale very easily the proving, where on the sequencer it's not the case for the moment. So the sequencer is currently the bottleneck, and it's clear that we are not worried of catching up the speed with on the proving side because of the nature of the proving that is asynchronous and parallelizable. This is why we put all efforts on the sequencing side. And one interesting thing also I want to mention is that, so I said that we run the Cairo VM in Madara as a core execution engine. But in the future, we will not run the Cairo programs directly with the Cairo virtual machine, but we will run a representation of those programs compiled in a native form. There is a project by Lambda class, which is called Sierra to MLIR. And basically, the idea is to be able to compile a Sierra program. So we haven't spoken about Sierra, but basically Sierra is an intermediate representation for Cairo. Why is that? Mainly because on the validity rollup, you can only prove a successful transaction. You cannot prove valid transactions. And this is an obvious DOS attack vector, because if someone spams you with invalid transactions, you cannot prove those transactions. And why it's bad? Because if you cannot prove them, you cannot include them, and it means you cannot take fees. So you can be spammed for free with invalid transactions. And Sierra is a solution to that. Because with this intermediate representation, there will be the guarantee on Starknet that all transactions will be provable. That means that you will be able to include the failed and reverted transactions. So that means that the sequencer will be able to charge fees on those invalid transactions. So this is very powerful. And Lambda class is working on compiling Sierra to MLIR, which is basically a native representation of a program. This is pretty similar to LLVM. For those who are familiar with that, it enables you to run crazy fast program because you will run a native representation of the program. And you will do that on the sequencer to drastically increase the throughput. But it's fine because, again, the proving will be done asynchronously in a parallel manner. So we can have huge boost improvements because of that. And we can benefit from this asymmetry. So this is very interesting. We'll update on that in the coming months when we have this working. And we will integrate that in Madara to drastically boost performances.
Okay. Hence the focus on sequencer optimization. I think there was an effort that was conducted to rewrite the Python sequencer on Starknet to a full Rust version of it. And you've taken the path for Madara to write it fully in Rust, as it's a rather performant language when it comes to building production systems, backends, etc.
Yeah,
that's definitely super interesting. And I would like to wrap up that first episode we do together on this channel with a few last words on your end on how to contribute on Madara and what's up next. I'm sure we'll get to chat again on on other problems and concepts.
Definitely, yeah. To say a few words about how to be involved in Madara. Basically, for Madara, what you can do is you can come to the GitHub repository, and we have a bunch of links. One cool thing could be to watch community calls where we do some deep dives on the substrate architecture of Madara. We do some deep dive of some implementation. We have also a contributor starter pack with a bunch of resources for you to start if you don't know Rust, blockchain, Starknet, Substrate, etc. And then we are using only this platform basically to reward contributors on Madara. So the idea is that when you contribute to Madara, once your pull requests are merged, you will be able to receive the payments using the platform. So yes, we are always looking for more contributors to contribute on Madara. So I encourage anyone to jump in on the GitHub and try to pick some issues, and we'll find people to help you from the community. So we have very welcoming people. You can join the Telegram group as well, and you will find the help if you need help. And we encourage everyone to come and contribute to those open source projects. We try to hopefully do a big demo of Madara during Starknet CC. And you know well of that because you are the organizer of Starknet CC in Paris. So just a small alpha, we want to plan a big demo of Madara during Starknet CC.
I mean, that's definitely very exciting. And I'll make sure that this is streamed on the Starknet CC channel if you cannot attend to the event, of course. And I was about to say that I'll leave all the relevant links in the description to engage with the project, to connect with the Madara community, to chat with Abdel or Daniel. And I think that that's it for this episode. I wish you a wonderful day, guys, and I'll see you on the next episode.
Thank you very much,
Thanks
guys.
so much, guys.
It was a pleasure. Thank you.